In session 44 here, we're going to look at solving simultaneous equations by using the subtraction method. If you remember from the previous lesson where we tried to solve simultaneous equations by your addition method, the priority or the goal when you try to solve simultaneous equations together is to do it in such a way that you eliminate one of the variables. Predominantly what we're looking at here is an x variable and a y variable. Getting them both together on the same side of the equation, whether the left or the right, and most often you'll probably see them on the left-hand side. And then what you're trying to do is to combine the equations in such a way that you cancel out one of the variables. Well, sometimes the addition method will not cancel out a variable. For example, if we took a look at our two simultaneous equations here, our first one, 2x plus 3y equals 12, and then our second one, minus x plus 3y equals 6. If we were to go ahead and add these together, well, a 2x plus a minus x would leave us with a plus 1x, and a positive 3y plus a positive 3y would give us a positive 6y. And then our right side would be 12 plus 6, which would be 18. But after we added these together, we would not have eliminated an x or a y variable. We're still left with an x or a y variable. So in this situation, solving by addition isn't really going to help us very much. However, we can solve by a second method called subtracting. And this is just very similar to adding that we looked at in the previous lesson, except in this situation you're going to be subtracting one equation from another. Well, if we took a quick look at our two equations here, if we were to go ahead and subtract the second one from the first, and what I'll do here is I'll just go ahead and put a parenthesis around this and put a subtraction sign out in front of it. Well, what would a 2x minus a minus x be? Well, you remember, minus of a minus is the same thing as a positive, adding a positive. Subtracting a negative is the same thing as adding a positive. So in this situation here, 2x minus a minus x is going to be a positive 3x. 2x plus x. If we come over here, we can take a look. Our 3x has not eliminated the x, but look what happens to the y's. When we go 3y minus 3y. Well, what is 3y minus 3y? It's 0y. So I could put here plus 0y, or to be consistent with what we had here, we're subtracting. We could say subtract 0y. Then over here on the right, 12 minus 6 is 6. Well, 0 times y is just the same thing as 0. So we could actually just go right back and erase this and leave it alone. And what we're left with is 3x equals 6. Now remember, whenever you add or subtract or multiply or divide in algebra to one side of the equation, you need to do the same thing to the other side of the equation by an equivalent value. Well, in this second equation here, it tells us that minus x plus 3y is the same thing as 6. So by the fact that we subtracted minus x plus 3y from the left-hand side, and then we subtracted 6 from the right-hand side, because those two are equivalent to each other, we've actually subtracted both sides of the equation by the same value. They look different. 6 looks different than minus x plus 3y, but we're told in this equation that minus x plus 3y has the same value as 6. They're equal to each other. Therefore, we can subtract the 6 from the right and the minus x plus 3y from the left, and we have not altered the equations at all because they are both equivalent values. Okay then, what we have now is 3 times x equals 6. So in order to get rid of the 3 that's being multiplied by the x, we need to divide both sides by 3. Well, 3 times x divided by 3 is just simply x. And then 6 divided by 3 is 2. So what we found out at this point is that the value for x that's going to work for both equations is when x is 2. Well, let's take it over here now and place 2 back into our equation. 2x plus 3y equals 12. Well, let's stick a 2 in there. What's 2 times 2? 2 times 2 is 4. Then we're still left with plus 3y equals 12. At this point now, what we need to do is solve it for y. Our x variable is gone. We're just left with our y variable now. Well, the first thing that we see here is that our y term, 3y, is being added with a 4. So to get rid of that 4 that it's being added to, we need to subtract 4 from both sides. Well, 4 plus 3y minus 4 is just going to be 3y. The 4 and the minus 4 cancel each other out. And then 12 minus 4 here is 8. We still need to solve for y. Y is being multiplied by 3, so to undo the multiplication, we need to divide both sides by 3. Well, 3 times y divided by 3 is just simply y. And then on the right-hand side, we have y equals 8/3. And I'm not going to go ahead and divide it out to get a decimal. We're just going to go ahead and leave it in fraction form here. 8/3. So we are now told that x is 2 and y is 8/3. So these values of x equal to 2, y equal to 8/3 should work now for both equations. Well, let's go ahead and stick in the value here. X equals 2. Well, what is 2 times 2? Well, 2 times 2 is 4. Stick in an 8/3 here for y. What is 8/3 times 3? Well, 8/3 times 3 is 8. What is 4 plus 8? 4 plus 8 is 12. 12 equals 12. So we know that these values work for the first equation. Well, let's go ahead now and take a look at the second equation. I'm going to go ahead and just remove those blue parentheses and minus that I stuck on it there, since that is now what our original equation was for our second one. Stick in an x for 2. Minus x is now a minus 2. So I'm going to go ahead here and write a minus 2. We're going to take our 8/3 here and stick it in for y. What is 3 times 8/3? Well, the 3 in the numerator here cancels with the 3 in the denominator in the 8/3. 3 times 8/3 is simply 8. And there's our plus sign. What is minus 2 plus 8? Minus 2 plus 8 is positive 6. And that's the value that we have over here on the right-hand side. So we can see here that our ordered pair, 2, 8/3, is the solution to both equations that we have listed here. And it's the only solution that'll work for both equations. So once again, we have solved two simultaneous equations here by using our subtraction method. Let's take a look here at a second problem. We need to visually take a look at what's going on here. 3x plus 4y equals 24. 3x minus 2y equals 18. And just remember, at any time during these sessions where I have a problem that's all by itself like this, and it's the second problem that we've done in the lesson, you can always pause your teaching video here, your algebra video. You just use your Windows Media Player and hit the pause button, and then you can try this problem on your own at home or wherever you're at on a sheet of paper. And then after you're done with trying to solve that equation, you can restart this video, and then you can see how I've gone ahead and solved it on screen for you. 3x plus 4y equals 24. 3x minus 2y equals 18. Well, if we add these together, 3x plus a 3x is going to be a 6x, and a 4y plus a minus 2y is going to be a positive 2y. That did not cancel or eliminate the x variable or the y variable. So we really can't solve this by adding at this point, because what we're trying to do is eliminate a variable. Adding won't do it. What about subtracting? Well, here you see you have a positive 3x up here in the first equation and a positive 3x in the second. Well, if we subtracted these two, then we would have our x's cancel out. So that's what we're going to do here. We're going to subtract this second equation from the first equation. Okay, 3x plus 4y minus 3x minus 2y. What's 3x minus 3x? 3x minus 3x is 0. 0x, and 0 times any number is going to be 0. So our 3x's cancel here. What's a positive 4y minus a minus 2y? Well, positive 4y minus a minus 2y is a plus 6y. Remember, when you subtract a negative, that's the same thing as adding a positive. And then over here, 24 minus 18 is 6. Then what we have here, we have the y being multiplied by a 6. So to undo that multiplication, we need to divide both sides by 6. 6 times y divided by 6 is just going to be y. And then 6 over 6 on the right-hand side there is going to be 1. So what we found out now is that for these two simultaneous equations, the y value that will work for both equations is going to be a y value equal to 1. So to find out what x is, we have to take our y value here and insert it back up into the equation. So I'm going to rewrite the first equation, 3 times x. I've placed in a 1 for my y. What is 4 times 1? Well, 4 times 1 is 4. So we're going to be adding 4, and that's still going to equal to 24 on the right-hand side. So why are we closer to a solution now? Well, we're closer because we now have just one variable left, x, and we already found out what our y value was, and we inserted it in there and calculated it out. Okay then, how are we going to solve for x? Well, our x term, 3x, is being added with a 4. So what we need to do is to subtract 4 from both sides. And what we're going to be left with on the left-hand side, 3x plus 4 minus 4 is just going to be 3x. Then over on the right-hand side, 24 minus 4 is going to be 20. X is still being multiplied by a 3, so to undo that multiplication, we need to divide by 3 on both sides. 3 times x divided by 3 is just simply x. Then on the right-hand side, I'm not going to give the decimal form. We're just going to leave it as 20 over 3. So when y is 1, x is 20 over 3. And let's go ahead now and stick this back into our original equation and see if it works. 20 over 3. Well, what is 20 over 3 times 3? Well, 20 over 3 times 3 is just 20. So we're going to go ahead and write that up there. And our y value is 1. What's 4 times 1? It's 4. 20 plus 4 equals 24. Stick this down into the second equation. 20 over 3 for x. Well, what is 20 over 3 times 3? 20 over 3 times 3 is just 20. For our y value, we have 1. What is 2 times 1? It's 2, but this 2 is being subtracted here. Then we do what's inside the parentheses first. 20 minus 2 is 18, but then we're supposed to subtract a positive 18. So what is minus a positive 18? A negative 18. So we're left with negative 18 on the left, and if we take a look at our right, we also have a negative 18. So it works there as well. And if we were to try to stick this back the way the equation was originally, before I subtracted it, if we want to just take a look at our original equation, which technically should have been what I did to begin with there, we can see that it also works with that one. Stick this back now into the original equation. I just cleaned it up there by erasing that. 20 over 3 for x. 20 over 3 times 3 is 20. Positive 20. 1 in here for y. 2 times 1 is 2. And this is being subtracted. 20 minus 2 is 18. So we can see, in fact, that that does work. So our ordered pair is x is 20 over 3, and y is 1. That is the ordered pair and the only solution for x and y that'll work for both equations. And then lastly, as a review, the subtraction method is just simply a method for solving simultaneous equations whereby you subtract one equation from the other with the ultimate goal of eliminating one of the variables during that subtraction. Okay, that'll finish up session 44.